Hi, my name is Alex Casal.
And I am Mitch Harvey.
What is unit testing? Before we get into the specifics, I'd like to briefly introduce its history. Back near the 80s, when the Smalltalk language was coming about, programmers of Smalltalk came up with unit testing. As word spread about unit testing from these developers, it gained awareness and C, C++, and Java developers started adopting its techniques. So then, what is unit testing? Well, its primary goal is to make the smallest piece of testable software in an application and to isolate it from the remainder of the code and to determine whether it behaves exactly as you expect. Okay then, so we're going to take small parts of our program and test them individually. How then do we know that the test itself was written well? The obvious answer would be if it runs our code and shows us if the results were what we expected. But there is a process to this. There are 6 qualities that ensure a unit test was written well. They are automated, repeatable, easy to understand, incremental, easy to run, and fast. We will go into these further in the next slides. Again, the first 2 were automated and repeatable. This means that other team members can repeat running the application unit tests for every significant code change automatically. Essentially, we are creating driver and stub functions. Functions that stand alone to simulate the conditions the code being tested will run within. The great thing about drivers and stubs is they can be reused. They are completely standalone and have no other dependencies. Their sole purpose is to test a single action or event. Once these actions have been isolated and tested for correctness, the code being tested can be integrated into the actual system. Okay, the next one is easy to understand. Simply, it should be easy to understand so that other team members can understand what your test means and can continue adding more test cases or updating an existing test case. So pretty much, is your test simple enough that someone can look at it and know exactly what's going on in sequence? Or is the test trying to perform complex operations in between testing each function? It shouldn't be doing these complex operations. That's what it's testing, is the other functions doing these operations. Okay, incremental. The unit test should be updated if a new relevant defect is detected in the code, which means that this defect will not happen again as long as this unit test is running periodically. So say your test is running fine and later you make changes to the code which break the test. Then the test should be revisited and rewritten such that it will show the correct results again. Easy to run and fast. The test should be run by executing a command or by clicking a button, and it should not take a long time for execution because fast unit tests can help in increasing the development team's productivity. Essentially, these tests should be straightforward and simple. They shouldn't be overly complex, taking long amounts of time to execute, because they are only focusing on small aspects of the program. Okay, the real question. When do we actually need to use unit testing? Unit testing should be a mandatory activity for having a successful software solution that can cope with different changes across time with high stability. Additionally, the importance of unit testing may not appear in the early stages of the project. However, its advantages are visible in the middle and final stages of the project when the code gets complicated. More features are required, and more regression defects appear. Essentially, this should be integrated into every project throughout its entire life cycle. By keeping the unit tests updated with the 6 points we mentioned before, it should help ensure a good quality software without any bugs.
Test-driven development, or TDD, consists of multiple categories of tests. Each has their own strengths and uses throughout the software development process. Unit testing is the most basic kind of test you can use, and ideally, unit tests should only test one part of a program at a time, a single aspect of a single function. Test-driven development works effectively when these categories of tests are used appropriately. Each has a specific task or phase in the process that they work especially well for. Manual testing, where the developers manually use a program to test it, requires the program to be well into the development process, and as such, It's useful for finding bugs, but would not be effective at the beginning of a software project. Adversely, unit testing is very effective at the start of a project. It's great for developing and validating small parts that, once proven correct and effective, can be added to the larger whole. This makes unit testing great for designing software components, but a poor test choice for finding bugs or regressions, which are things that used to work but have unexpectedly stopped working correctly. Test-driven development utilizes the test-first approach to software development. This means that tests are created before developers ever begin writing the actual code. This helps developers brainstorm and know ahead of time what their function needs to accomplish, while also ensuring that the unit being tested is able to fulfill its required role. In order to know when it's best to use unit testing, you need to understand its strengths and weaknesses. The main strengths of unit testing aren't necessarily apparent right at the start of a project, but further down in the line of development, a lot of problems are either mitigated or avoided completely. When you perform unit tests on each unit, integrating those units into the project will result in less bugs and problems overall. And when a bug does occur, you know which units work, and that helps you find the root cause of a bug. And on top of bugs, unit testing is great as a source of documentation, and it provides consistent testing methods. As far as weaknesses go, there are a few important things to note. Unit tests are not always the most appropriate choice for a problem, such as when you're trying to find out why an aspect of the project that was working is no longer working. You need to pick a test that deals with multiple functions, and unit tests just deal with the most basic block of software. Unit testing also costs additional money to write and execute the tests, which translate into money spent paying someone to do that. Unit tests need to be updated whenever code is updated, and the advantages are not always apparent until later on in development. A good unit test means that it's designing a single component, one aspect of a single function. Anything more than that is leaning towards integration tests, or a hybrid between unit tests and integration tests, and these are always bad. A true unit test is what's desirable. Here's an example of a unit test in Java. The test method email validator verifies that the isValidEmail method in the app returns the correct result. It tests one small thing in a function and nothing else. Thank you for watching our presentation. I hope that it was informative and entertaining.